In this video, we're going to learn how to solve linear equations. So let's start off with a very simple linear equation. So let's say we have x plus 2 is equal to 8, and we want to solve that linear equation. So whenever you're solving for a linear equation, you're trying to solve for a variable. So in this case, our variable is x. So what does that variable represent? So in this case, it represents some value. So what value in this case, so what would be that x, when you add it with 2 will give you an 8. So if you think about it, this is a very simple one right here. So what plus 2 will give you 8? It's 6, right? And so that's a very simple linear equation, which you can just look at it and tell what would be the answer right away. However, it's very important to know what are the steps that can be used to actually solve for that variable to get that 6. Because when we have complicated linear equation, that's when you're going to use those steps to solve for the variable. So in this case, whenever you're solving for the linear equation, for the variable x here, you want to undo the operations. Okay. So in this case, here you have positive 2 right now, x plus 2. You want to do the opposite operation of positive here. So you want to get rid of that 2. So you want to subtract 2 on both sides, because the opposite of positive is negative. So you want to subtract 2 on both sides so that you get rid of that 2, because positive 2 and negative 2 is a 0. And then you're left with the variable x. Now 8 minus 2 gives you a 6. All right, and so that's how you got that 6. So now let's do a little more complicated one. So let's say we have 2x plus 4 is equal to 24. Okay. So in this case now, you have a coefficient on the x, and you also have one more constant added with it. And so now our goal is to isolate the variable x. So you want to, again, undo the operations here. So I'm going to start with that positive 4. And so you want to subtract 4 on both sides. And so in this case, positive 4, negative 4 becomes 0. And then you are left with a 2x, 24 minus 4, which is a 20. And then here in this case, right, our goal is to completely isolate the variable x. So you have 2 times x, right, because it's 2x. And so now it's a multiplication right now, right, 2 multiplied by x, which is a 2x. So you need to do the opposite operation here. So in this case, the opposite operation of multiplication is division. So you want to divide both sides by 2. So 2 cancels out, so you're left with an x. 20 divided by 2 is a 10. And so your value for this variable here in this equation is 10. And we can go back and check it, right? So 2 times 10 gives you 20, and then 20 plus 4, so 2 times 10 plus 4 is that going to give you 24, right? 2 times 10 is 20. 20 plus 4 is definitely equal to 24, and that satisfies that equation, okay? And so the value that satisfies this equation is 10, okay? Now let's do a fractional coefficient linear equation. So let's say we have 1/2 x plus 2 is equal to 1/4 x plus 3. Okay, so there are a couple of ways you can do this. So we'll do 2 ways, and we'll still end up, so there are different methods you can do this. You'll still end up with the same answer. So the first way is get your x's on one side, okay? So your goal is to get all of your x's on one side, and then try to isolate that x, and then you'll have your value for x, okay? And so what we're going to do here, we have 1/4 x and 1/2 x. So I'm going to bring that 1/4 x to the left side of this equation. To do that, remember here, this whole thing here, 1/4 x is positive. So to get it to the left-hand side, now you need to do the opposite operation. So you're subtracting 1/4 x on both sides. And so in this case, so 1/4, positive 1/4 x and negative 1/4 x turns out to be a 0. So you're just left with a 3 on the right. And then here you're left with 1/2 x minus 1/4 x plus 2 is equal to 3. All right, now you have your x's. We still got a 2 there, so we also want to get rid of that 2. So let's get rid of that 2 first and then deal with the x's. So here we have a positive 2. So we want to do the opposite operation. So you want to subtract 2 on both sides, positive and negative 2 turns out to be a 0. Then you're left with 1 half x minus 1/4 x is equal to 3 minus 2, which is a positive 1. And now let's deal with the left-hand side. Right here, right now, you can't really subtract these two fractions right like this, right? Because we don't have the same denominator. And so now your goal is to somehow make it the same denominator. So you can go the least common denominator route, or if you look at this, right, on one we have a 4, on the other one we have a 2. Now if we multiply this first one, top and bottom, by 2, right, what is 2 divided by 2? It's a 1. We can always multiply anything by 1, right? It's not going to change that, that expression. And so in this case, if we multiply 2 over 2 here, we get, when you multiply across, 2 times 1 is 2, 2 times 2 is 4, x minus 1/4 x is equal to 1. Now we have the same denominator, right? So when we have the same denominator, we can subtract out the top. So 2 minus 1 gives you 1. And then you have the same denominator, which is 4th. And so 2/4 minus 1/4 is 1/4. And so you have 1/4 x is equal to 1. And now you need to get rid of that 1/4, right? So in this case, remember you have 1/4 times x. And so you want to divide both sides by 1/4, right? So you want to divide both sides of this equation by 1/4. And so 1/4 divided by 1/4 is just 1. And so you're just left with 1x, which is just x. And so you have 1 divided by 1/4, which is, so you can write this as 1 divided by 1/4. And then if you remember this from middle school, right? When you were dividing fraction, what do? Copy dot flip, right? Remember that? So you convert that division problem into a multiplication. So 1 times 4 over 1. You flip the second part of that equation. And so you get 1, and you multiply across. 1 times 4 is a 4 over 1, which is basically a 4. That's one way, right? And so your equation here gives out a value of x as 4. And so we can also do that same problem in a little different way. So I'm going to copy that problem, and we go a little other route, okay? Okay, so in this case, we can also do this problem a little differently. And so in this case, let's look at our denominators, right? So what are our denominators of our fractions? So we have a 2 and a 4. So what is the least common denominator of 2 and a 4, right? And we know the least common denominator of 2 and a 4 must be 4. And so now the concept here is you want to multiply that whole equation by 4. So if you do that, what happens is that all of your denominator cancels out, and then you will not have fractions anymore. And so let's go ahead and do that. So multiply by 4 on the left side of this equation, and then multiply by 4 on the right side of this equation. And so remember, when you're multiplying by a number here, you want to distribute that number into each of these parts. And so you want to distribute that 4. And so you have 4 times 1/2 x plus 4 times 2 is equal to 4 times 1/4 x plus 4 times 3. Okay. And so 4 times 1/2 is basically 2, right? And so you have a 2x plus 4 times 2 is 8 is equal to 4 times 1/4 is basically 1, because that, remember here you have the 4 on the top, 4 on the bottom, those cancels out. And then you have just a 1x. And then 4 times 3, which is a 12. And now your goal is to get the x's on one side. So here we have a positive x on the right-hand side, so I'm going to bring it to the left-hand side. And since it's positive, we want to do the opposite of that. So I'm going to subtract x on both sides. And so I have 2x minus x, which is an x. And then plus 8 is equal to, and remember here, positive x and the negative x cancels each other out. And then you're just left with a 12. And so now your goal is to solve for x. And so we want to isolate x. Here we have a positive 8, so we want to get rid of that positive 8. We're subtracting 8 on both sides. And so x is equal to 12 minus 8, which is a 4. So no matter which method you use, you still end up with that same answer, which is a 4, right? So this second technique here would be easier when you have fraction with the denominators that are different on each of these part of the equations, okay? And all right, that's it.